Hello, students. Oh, sorry about that. Um, we're just continuing on from our lesson that we had last week, or essentially 9.5, or inverse trigonometric solutions or integrals. Now, last time, or the last lecture, so please go over and make sure that you kind of reviewed at least the last problem or the last lecture lesson in general before you go on to this part here. Okay, so don't worry about this here. So there is a little delay in my video and my writing and my talking. So I'm going to try to slow down and try to make sure that it's just my camera's picking up things really slow. So I have to kind of talk slow to kind of make sure they coordinate. So excuse me, okay? Just a little preface right there. So anyways, we were given this problem last time of the integral of 8x over 3 plus 4x squared. And it wasn't like our typical solutions with having a inverse trigonometric solution to this integral. We ended up having just use basic substitution. The clue was that on the bottom in the denominator, you had like a variable which was 1 degree higher than what was in the numerator. If you try to do use an inverse trigonometric solution, you'd be stuck because that x you can't find a way to substitute that x. So it was just use substitution, and if you set your u equal to 3 plus 4x, you'd find out that your du is just 8 dx, in which case you can substitute 8 in dx with du, and then your u would just be down here. The u would replace 3 plus 4x, so you'd end up having this you take the integral of 1 over u to du, and there you go. It'd just be ln of u plus c. That's it. That was really easy. Let me go over something that's a little bit trickier, I think. Okay, so don't worry about this. Okay, so let's go ahead and begin. It's going to be a little bit tougher. Oh, sorry, those are my notes that you guys just heard. Let's see here. Okay, so what if we had this integral here? 4 minus x squared with respect to x. Okay, this one's a little bit tricky. It looks pretty simple because I see a x squared and an x. So on the exam, when you see something like this, right, where it looks pretty tricky, the first thing you want to try to do is use substitution, right? So let's try use substitution, kind of like what we were doing before. So I'll just make u whatever we're taking the square root of on the bottom, so it'd be 4 minus x squared, okay? U, and let's try, and the du would just be negative 2x with respect to x. All right, looks good so far. I mean, I have an x at the top, and I have a dx right here. So all I would have to do now to make it look more like x and dx is just to divide both sides by negative 2. I think some of you guys already have a problem with this, which is good, because there is a problem with this. Then you have negative 1/2 times du is equal to x times dx. That's x times dx. So that means I can replace the x and dx with a du statement that is completely equivalent. Cool. So that looks great, right? And then I got the u down here, and then let's go ahead and rewrite that. I know some of you guys are like, you didn't address this other problem, Mr. Wee. Let's see, u square root of u over, let's see, du, right? That looks pretty good. I mean, then there's a times negative 1/2 technically, which, since it's being multiplied to a constant, then I could just pull that out to the front. But wait a minute, Mr. Wee, you're forgetting one thing. How the heck are we going to solve for that plus 4 thing? Okay, so the truth is, u substitution is not a solution. So no. As an x, this is not a solution. So then our next logical step would be to go to an inverse trig function. So inverse trig, so if you grab your cheat sheet, we know that if you have a statement that looks like this, we have a u prime, or du basically, at the top, and then you'd have a square root of a squared minus u squared with respect to dx, which I just picked this inverse trigonometric solution because it looks, out of the 3 different ones on your cheat sheet, this looks most like this, because you could have used, so here's like a cheat sheet you could have had, or it's not the cheat sheet you have, but here's two different solutions, inverse trigonometric solutions. If you have a square root at the bottom where you have a constant minus u squared, some kind of variable squared, then you should have a solution that has sine of or inverse sine or arc sine of u over a plus c. Or if you have it in such a way where you have a variable, maybe some kind of variable at the top here, or I'm sorry, the derivative of the variable at the top here over a constant plus u squared, then you have arctan. So let's try this. And I think what I'm basically saying is we have a square root. We for sure have a square root statement at the bottom, and a constant is a variable squared is being subtracted from a constant squared, which is what we have. Constant squared minus variable squared. Cool. All right. So let's just, and basically the solution would then be inverse sine or arc sine, however you want to say it, of your u over a. Yeah, not too bad, not too shabby. So let's try that out. Okay, so again, this is what we actually have, and this is the proposed solution. If I can identify all these things, replace them perfectly. So let's try that. So we have a squared will be 4. Okay, and then your a would then be 2. All right, fair enough. And then your u squared is technically x squared. And let's just define u by itself. That would just be x. And then u prime would then be 1 times du. All right, off to a good start. Oh, sorry, it'd be not 1 times du. It'd be 1 with respect to x. Okay, because the derivative of u, okay, when u is equal to x, the derivative of that would be 1 times dx. Okay, so let's compare that to what we have over here. All right, well, I got 4 in dx, so I could say that, well, you'd have something like this, essentially. You'd have 1 dx, not 1 dx. You'd have, let's see, square root, no, I'm sorry, I apologize. So let's see if we can replace all the terms that we have here with this. Then we can write it in inverse sine of u over a. So let's see if that will work out. So here I do indeed have an a squared, my a being 2, that'd be 2 squared, minus my x being squared, Cool, all right. And then I got 1 dx. Well, there's that pesky 4 there, okay, which I can kind of replace with that 1 dx. That's not a problem there in place of du, but you can already see, I already see a problem here. 1 4 prime. That's actually not bad. I'll get back to that. But the thing is, this makes no sense. This has no place in what we should have here. This should just be u prime at the top, and u prime is technically fine. And having the 4 there is fine. Okay, I'll explain why, or we'll kind of review why. But x, though, we have no place for that. That is not covered in terms of u prime being at the top. That is not u prime. Okay, so again, we have a situation where this doesn't work either. So now what do we do? Well, the truth is, this problem has bits and pieces. If you have, so in the future, if you have a denominator that looks similar to some kind of solution that we could use, like an inverse trigonometric solution or integral solution, meaning that 4 minus x squared resembles like one of the inverse trigonometric integral solutions, like it's a square root of a squared minus u squared, or a squared plus u squared on the bottom, okay, which we have, I'm sorry, and then we have the constant here being added, a constant that is 1 degree lower than the bottom if we have not a constant, if we have a variable that is 1 degree lower than the variable at the bottom here being added to a constant, then what we're going to do is a solution which requires both these methods. How, you ask? Well, I'm going to show you, but this solution for this is going to be very tricky. It's multi-layered. It's going to require both of these techniques. How? Well, let's go ahead and take a look at our problem again with a different perspective. We have the integral of x plus 4 over, let's see, what was it? It was a square root of, how can I not know this by now? It's a 4 minus x squared dx. Well, we're going to do what's called the sum rule. And the sum rule actually just goes along with what we've learned about integrals. You have an integral of two things being added together over a similar denominator. You can split them up into two different integrals being added together like this. So we'll just separate the x and the 4 and then keep the denominator for each statement, and then you're going to have two integrals being added together. This is a perfectly acceptable way to solve this problem. And I'll tell you this, just from our previous experience from the last problem in our last video here, we knew that if you had some kind of constant being multiplied to a variable, it could be a constant being multiplied. We don't have this here. By the way, just letting you know that the reiterate x and 4 were not being multiplied, but I'm just saying that if you had some kind of constant being multiplied to a variable that's 1 degree lower than the variable at the bottom, okay, like meaning this is x to the first power and this is x to the second power, that's what I mean by 1 degree lower, all right, then we're just going to use u sub to solve for this. And then for here, we're going to use the inverse trig solution for this one, meaning we can use the inverse sign of u over a for a solution here. Okay, so here, and then at the very end, we'll just add both the terms together. Very tricky, very, very tricky. So let's solve this piece by piece. You can pause right now and try this on your own, and then just kind of meet with me if you kind of get the idea, or you can just follow along with me from our notes. So your u substitution starts with setting your u, and then we'll just go back to our original idea of saying that was 4 minus x squared, and then your du is going to be negative 2x squared, or negative, not negative 2 squared, it's negative 2x with respect to x dx, okay? And then we're trying to substitute x dx, x times dx, or x with respect to x here, or with du. But we have to make this look exactly like x times dx, which would require you to divide both sides by negative 2, and the negative 2's will cancel out, and what you would have is negative 1/2 du is equal to x dx. And you're going to find that it's going to work better than the last attempt that we tried when we tried u substitution, because the 4 is no longer with this x at the top, so we can actually do a successful u substitution this time. So you're going to end up having, let's go back to this and let's replace all these terms with u's, everything in terms of u, and you'll see that works out beautifully. This will be the square root of u technically on the bottom, and at the very top is technically negative 1/2 du, okay? Remember, we're replacing x and dx with everything in terms of du, but we do have to include this negative 1/2. And if you remember your law of you remember your law of exponents, this negative 1/2 will go to the front because it's just a constant being multiplied to this, so it's not significant. So now you can have negative 1/2 times the sign, or not the sign, the integral of, I'm going to split this part, 1 over the square root of u with respect to du. I'm going to separate this out, okay, because the du is not really going to help in this position, so I'm going to kind of move it out, and it's the same thing. It doesn't lose any of its inherent value. It's still the same. These are equal, okay, if I write it this way. It's just now I can see that if I rewrite this again, I could rewrite 1 over u, or square root of u, as 1 over u 1/2 du with respect to u. That's 1/2, u 1/2. Again, if I rewrite that again just to double check and see, this is u to negative 1/2 power. And can I take the integral of this? Well, okay, so just pretend that constant wasn't there. And if we take the integral of this, you should get u to the 1/2 power. And the constant that had to be in the front was 2. I know that's very, very confusing. Plus c, by the way, that would be your solution. I know that's very, very confusing, but if you think about it, okay, don't worry about that negative 1/2 constant here, okay? All right, when you're just taking the integral of this, it makes sense that it's 2u to the 1/2, okay? Because if I took the derivative and went back to the integral here, if I took the derivative of this guy, then I would do this, I would bring down the power, which is 1/2 as a coefficient, it'd be 1/2 times 2. That makes sense because there's no coefficient here, okay? And then I would have to subtract 1 from the exponent, which gave me negative 1/2. And then now I have negative 1/2 here. Now I can bring down the negative 1/2 here, which was in front of the integral. My final answer should be negative u to the 1/2 plus c. And that would be essentially negative, if you go back, my u I set was equal to 4 minus x squared. 4 minus x squared 1/2 plus c. If you don't like that, it's negative 4 minus x. Whoops, actually, I'm just going to rewrite that a little bit differently. It'd be essentially negative square root of 4 minus x squared plus c. Let me rewrite that so it's a little bit more clear. If you don't believe me and you had a little bit of trouble with the coefficients part here, I would recommend you right here at this step to take the derivative of this. Why don't you take the derivative and see if you can kind of go backwards? Or actually, why don't you just take the derivative of even this bottom statement here, and then you should be able to go all the way back up to here successfully, okay? That would be a good way to check if this is correct. And I will tell you just ahead of time, if you need to rewatch this a few times, this is a video that's worth rewatching a few times or rewinding a little bit more, you know, to kind of get down a few times. This is the actual proper solution, okay? You just have to kind of make sense of this. Okay, so now we're not finished though. That's just 1/2 of this problem. The other half remains up here. It's still very tricky, okay? It's good exercise though. Good for your health. So our solution, I would say step 1 is to kind of list out what we're looking at here. We do want a solution of u prime over the square root of a squared minus u squared. With respect to dx, I know it's a little bit odd. If you take the integral of this, then you would get inverse sine of u divided by a plus c. Okay, so let's first define these things and see if we can replace them in here successfully. So u prime, or I'm sorry, not u prime. Let's first set your a squared. So a squared looks like it's going to be 4. So a squared will be 4, making a just equal to 2. Okay, then your u squared, if you think about it, should be x squared here. This is very tricky, so be very, very careful, but your u would just be x, and then guess what your du is going to be? It's going to be du is equal to 1 times dx, or 1 with respect to x. It's the derivative of this, which is x, is just 1. But don't forget, it's still in terms of x. So here is a very pivotal step. Sorry, it's not just du, but you can also rewrite this as u prime, just like how it's written. They're both the same thing, but the thing is our cheat sheets do say u prime, so let's kind of keep it consistent. U prime is a little bit different. It's 1 times dx, and then our actual answer is 4, but that's okay because we can write it like this. So let's, before we put everything into here, let's check out to see if we can replace all these guys, or I'm sorry, all these guys here with all our values here successfully. Okay, so you're going to have, let's say, you could see at the very bottom, let's start with the bottom. I always like starting with the bottom. Your a squared should be 2 squared. That works out. Minus x squared. Okay, that looks good. And then here, your u prime, I can actually replace 4 in dx with u prime if I multiplied it to 4. Because again, u prime is technically 1 dx. Here we have 4 dx. In order to substitute in 1 dx u prime up here, we have to take in consideration that what we have in the original statement is 4 times bigger than what we should have as u prime. U prime should be just 1 dx. This is okay. This is still a constant. We don't have a crazy variable up here to worry about anymore. They're separated now. 4 is by itself, so it's just 4 dx. All we have to say is that u prime can be replaced. It's fine. We can just plug in u prime. But since 4 dx is 4 times bigger than 1 dx, which we should get, that should be u prime, we're just looking at 4 times u prime. And the reason why this works is you can literally just take out 4 and put it in front as a constant. So now you have this. Perfect. 2 squared minus x squared, and you take the square root of the bottom there. And then u prime here, or if you had to replace it, if you had to look at it, it's just 1 dx. Okay? I don't know if that makes a little bit more sense, but pause and kind of review over your notes and review my notes. But trust me, this is going good so far. This is actually good. Okay, this is successful, right? So now let's rewrite this in terms of sine of u over a plus c. We see our u, which is just x in parentheses, and then our a is 2. Okay, so we have that 4 times sine of u over a. So this whole thing will be replaced as u over a, sine, inverse sine of u over a, which would just be x over 2 plus c. Okay, that's it. So now this here will be added to this. Remember, the original thing was, or the original premise of this was, if you have a situation in integral where you have a denominator at the bottom that indicates that you will have an inverse trigonometric solution, integral solution, which in this case will be an inverse sine. But at the very top, you have a combination of 2 different scenarios and issues. You have a variable that is 1 degree less than the variable at the bottom, which we sort of remember at the very beginning, or at the very end of your last video, was it's simply u substitution. But we're also met with the situation where you have a nice clean variable here, that plus 4, that would indicate to you that you just use inverse sine or inverse tan as a solution. It's a combination of the two. That's what it is. So we separated the variable and the constant, and in the constant, in this corner, in this constant here, you would use the inverse trig solution. And in this corner here, where we have a constant at the top that's 1 degree less than the constant at the bottom, that's going to indicate that you use substitution. But that was just a trigonometric rule. We just that was the integral rule, where if you have 2 terms being added together under a certain similar denominator, you can technically split them off into 2 separate numerators with the same denominator, and at the very end you just take the integral of both of those guys and you add them. I took the integrals of both sides, and now my final answer should have this plus this. So if I had to rewrite my final answer, it would look something like this. Negative 4 minus x squared plus c plus, so that was the left side, plus 4 sine, or inverse sine of x over 2. Let's see. Did I do that correct? Yes, I believe I did. Let me see. Sorry. I just want to go back. I always make mistakes in my notes. Did I forget something? Nope, I did not. Okay, perfect. This video is pretty long. Have you noticed, right? This is my second take, guys. So just letting you know, about an hour and a half has elapsed already trying to get this video correct. Okay, so this looks fine and dandy, but your exam, if this was a I don't think this is a multiple choice problem. This never will be, okay? But I think at the very end, to make this a 5-star quality answer, not from going from a 4 to 5-star quality answer, this C and this C, if you combine like terms, will be kind of like this. It'd be 4 minus x squared plus 4 times this inverse sine of x over 2 plus 2c. Sorry about that, guys. That's just my phone. Okay. Plus 2c. This in itself, because it's just a constant being multiplied to 2, is still going to be some kind of constant. So it's still going to be some constant c. So my final answer would just be this. Eloquently put. It's not very eloquent. It's pretty messy here, but this is the most eloquent it'll get. It'll be negative square root of 4 minus x squared plus 4 inverse sine of x over 2 plus a singular constant. Again, 2 times a constant, again, will just be some constant. So we're going to write it as just one giant big constant there. And that's your final answer, okay? All right, guys, go ahead and study this quite a bit. This is a very tough video. You guys have a great night or great day and great week. Okay, good luck. Bye.